I was not accepted actually for the graduate program. So I ended up at Stanford. And being a PhD graduate from Stanford, of course, I joined a bunch of startups after. Startups going all the way from, I was first employee. I didn't really found a startup, maybe, I'm giving myself target of a few years from now, but I did join as first employee for startup, joined a startup that just got bought soon after, and also joined a startup that right after it was bought, which then led me to my current job. I'll talk about it later. That is pointing to, guess which place is that? Of the world. Imagine there's a globe there.
Silicon Valley.
No, Silicon Valley is there, by Stanford.
Oh.
That's actually France. So I'm married. My husband is from France, Alsace, France. He's also a video geek like me. We have 2 kids, 2 small boys, 3 and 5. They're both malikot and makulit. They're 2 words I cannot translate into English. I can say it in Tagalog. Now, my job at Netflix, as I said, I joined various startups in Silicon Valley, ended up at Netflix, and I've been there for the past 5 years. Been very happy with my job, and that's my role. I'm actually director of video algorithms. So I do not direct TV shows, which what some of my nieces think back in the Philippines, I direct TV shows. But in short, I'm responsible for all the software development and research that is related to encoding the video streams that you watch on Netflix. So who here watches Netflix? Hopefully everyone, yeah. So that's the technical term, but really what I'm responsible for is that if what you're watching looks bad, that's my fault. So if you see any blocking or any noise in the TV shows or movies that you're watching, that's, you can send me an email because there's a bug and we have to fix it. So from a day-to-day basis, what we do is we build a system at scale. So you may think, encoding these videos are simple, but really to do this at scale, I think one of the speakers talked about it earlier. In Silicon Valley, it's important to do things at scale. And being a big company, we're not big yet, but we do stream a lot of video. Doing this at scale is very important. So that's on a day-to-day basis. So my team is composed of software engineers as well as research scientists. The second thing we do is we do applied research to make sure that what you watch is good quality. So we're sort of in the cutting edge of the technology. So a lot of these problems haven't been solved yet. So we have to do the research in-house with a very product-oriented mindset. So not research so that we can write papers, but research so that we can send these better video streams to you guys. And we also do long-term strategic research and standardization, and we do research collaboration. So what that means is that Netflix is not just thinking about what the quality of the video today, but also tomorrow. So we're helping out build the technology. A lot of the technology that we're using is standard. Industry has to use it so that there's interoperability. So we're doing that. So, but simply put, too, what I do is this is one of the more fun parts of my job is I go network. I go to different places, talk to other companies so that we can agree on standard technology. And next week, I'm actually going to be in China, partly doing this, helping standardize the technology. So why is this important to Netflix? You can't see the numbers, but this is a pie chart of the downstream internet traffic in the U.S. and then North America. And this blue part here is Netflix. So this is the whole traffic. So 35% of what's passing through the internet pipe at night at 7 p.m. when people turn on their TVs is Netflix streams. So anything that we do from compressing the video, making it smaller, making it look better, affects internet congestion as a whole. So this is what I think about to motivate me. Squeezing out 10% of bits can affect this greatly, and people can watch, enjoy their TV shows better without any rebuffer and bad blocking. So we're asked to talk about 2 work that we did recently, just to give you an idea of what we do. So one project that I did recently, which I started off as an individual contributor, then that 5 years ago, and then eventually we deployed it just early this year, is finding better ways to encode our video. So we encode, cartoons like BoJack Horseman. So who likes BoJack Horseman? That's actually one of my favorites. All the way to like action movies, right? And in the past, we were just doing the same thing for all these movies, but really for BoJack Horseman, even though it's a great show, you don't need that same amount of bits to send. So we were wasting all these bits. But for an action movie, you need more bits because there's lots of motion, there's lots car chases, explosions. So you need more bits for that. So it seems simple too, but to be able to do this at scale and tailor to every single movie, you have to do a lot of research. So this is what we did, and we actually launched this. There were a bunch of articles in December. I was quoted in Variety, like my 10 minutes of fame in Variety. Even though it's an entertainment magazine, they also talk about engineering. And we had clippings from Time, TechCrunch, and all that. I showed you the 35%. Actually, last year it was 37%, but more people are still watching Netflix, but since we compressed it better now with the same quality, this actually dropped to 35%, and we're continuing that way. This one is another project that we're doing. We want to deliver the story as low bit rate as possible, so 250 kbps. So now that Netflix is global, especially places like the Philippines, you may know people are accessing internet there using their cellular phones, right? Not using fixed lines. So that means it's very, very low bandwidth, and more importantly, I feel there's data caps. So you may know, whoever has been to the Philippines, like you pay for 500 megabytes of data, for example, for $5. Do you know how much Jessica Jones you can watch with 500 megabytes? Only 1.5 episodes of Jessica Jones. So that's gonna really suck. You wanna watch the whole season, right? So that's something that my team is working on. Let's try to squeeze it down to as small as possible, but still give it at the good enough quality so that people can still enjoy the story. And this is just some ongoing work. Just if anyone are interested in like the details of the technical part, just come ask me afterwards. Thank you.
Hi, I'm Nick Kridler. Let's see. Oh, yeah. So a little bit about me. I'm actually from the East Coast. I grew up in Western Maryland, where until I got to college, I was the only Filipino person that I knew. So I went to University of Maryland, Baltimore County, where I studied applied math, and then I eventually went to a PhD program at Colorado, but found out that PhD was not right for me. I'm also a builder, and I got to the point where I realized that a PhD in math meant proving that a solution exists, not actually solving a problem. So I dropped out, and I got a master's degree. And then I started working in defense. And so for the better part of a decade, I worked in the area of like remote sensing and signal processing, basically trying to find bad guys, or in this case that I put here, I worked on a project where tried to image the ground through dust. So in Afghanistan, some of these helicopters can't see the ground because of all the dust that comes up, and so we created a LiDAR system that images any sort of like potential problems that we can land safely. And so while working at Arte, I learned all kinds of skills that are not very widely used today. So our primary code base was in Fortran. I don't know if any of you are familiar with Fortran. Right? So I worked in a program that was very old, and so we had a lot of these like legacy codes. And for scientific computing, Fortran is actually a perfectly fine language. But that's also where I learned C and C++ and machine learning and that sort of thing. And so under the Bush years, working in defense was great. The business was booming. But then it eventually got to the point where like defense was actually shrinking. And so I needed a way to get out of defense. And fortunately, there was this data science competition website that came out called Kaggle. And I competed in a number of competitions and actually won 2. I got 8th in this really big one for the Heritage Health Prize. And I basically showed that using the same techniques that I was using in defense, I could solve other kinds of problems. And so from there, I went and did some other data science stuff. I worked at a number of different companies. And now, since 2014, I've been at Stitchfix. And so I'm going to talk a little bit about Stitchfix and sort of like what we look for in data scientists. For those of you who don't know, Stitchfix is a fashion company. And we send a box of 5 clothes selected from a stylist. And The stylist picks things that are 100% recommendation driven. So we have a giant data science team. It's like 80 people. We have an algorithm that decides whether or not you're going to buy a specific item in our inventory, and then the stylist goes in and from those recommendations picks what they think is going to work for you. So I work on the merch algorithms team, and merch algorithms covers everything related to the inventory. So what should we buy? Which warehouse should it be? What types of clothing? And so I put on this like, ugly Venn diagram that I found where they like talk about all these different things that like you should have as like a data scientist, and communication, statistics, programming, business. And so I just wanted to like highlight the different things. So working at Stitchfix, you really do encompass all of these different parts of this like, Venn diagram. So we have this heavy like cloud stack where we're like doing stuff with Spark and Amazon cloud computing. We have to be very knowledgeable in statistics, machine learning, and all that sort of thing. We work closely with the business, so I work with buyers, people who go to the market and find clothes that they're going to buy. We actually, the data scientists, designed this top right here. So it was one of our best sellers. It's called the Curie. Basically what we did was we looked at a bunch of different kinds of tops that were doing well, and we took different pieces and figured out which segments of our client base they would work for, and we just pushed them all together, and we call them Frankenstyles. And they're working out really well. And then the communication side is, naturally we're working with people who are not technical. They want to know, how many sleeveless bosses should we buy and why. And so you have to figure out how to put all the math and the programming into a story that they can resonate.
So hi guys, my name is Kevin Gabayan. I'm a software engineer at Google and formerly lead data scientist at Bump Technologies, which was that app where you bump the phones together to exchange contact information. And we were acquired by Google in 2013 to, after we pivoted into photos, because photos was the most shared thing about Bump Technologies, then it later became Google Photos. And so today I'm working on activity recognition, and this is a visualization of what activity recognition might look like for your mobile phones. So we use machine learning and huge amounts of data to make your 1.7 billion phones smart enough to know that what activities you're doing and how it can better serve your lifestyle. But this is a Filipino tech conference, so let's talk about Filipinos in tech. And so this is a little washed out, but these are the numbers from Google Diversity that were set out last year. And so I'm preaching to the choir here. The US Census race buckets don't capture Filipino underrepresentation. Tech roles at Google, 37% Asian, and this is in contrast to our experience of being the only Filipino in our class and our workplace sometimes. And so, so when we do push for Filipino diversity resources, and it's important to work with non-Filipinos for Filipino causes, and Talio really touched upon this really well, that by gaining allies that are non-Filipinos, then you meet all kinds of people that find diversity really important and are willing to learn the nuances of our challenges. And while also we work with non-Filipinos for their causes, like cooperating with the mature programs for Blacks, Hispanics, women in computer science. We learn so many different things about their programs that we can apply to our own diaspora as well. So I get this a lot. When you're talking to diversity resource people, they're like, but isn't Philippines a small country? And you've seen this before, but it's always great to have like some stats memorized about just so you can share with them, like, hey, Philippines is the 12th most populous country out of the some 195 countries there are in the world. We're more populous than any country that there is in the European Union, and for every 100 Chinese Americans, there are 84 Asian Indian Americans and 82 Filipino Americans, which is surprising even for Filipino Americans as well. We make up 6% of the Bay Area population. So if anyone asks you, are Filipinos underrepresented in tech? Hey, then you can tell them like, well, are 6% of our workplace Filipino, or of our engineering class Filipino?
1% probably.
I'm sorry?
1% probably. For virtual reality, I think it's 1%.
1%, often less than 1%. Yes. So, keep on pushing. Google, recognizing this, has the Generation Google Scholarship, and by us working with our non-Filipino allies, then I'm happy to say that last year was the first year that Filipinos / Native Hawaiians / Pacific Islanders, for the first time, were listed as underrepresented computer science groups that are targeted for this scholarship. So please raise your hand if you are Filipino studying computer science. Awesome. So I want every single one of you to apply for the scholarship. We're going to send out a link, details later on. So I'll just punch through these slides. I'm working on activity tracking, gesture recognition. All these technologies help your phones know what it is that you're doing so it can better serve you. This is what the motion looks like on your phone. Anyone work in motion tracking and know what, has seen motion data before? You see, this is the XYZ axes, and then you see oscillation in the Z axis, about once per second over here. Any guesses as to what this activity is? Once per second.
Walking, playing Pokemon Go.
Yeah. So it also could be biking. We're not sure yet, but if you take a look at the watch accelerometer, then the orientation isn't changing at all. So there's no oscillation in the watch. So it is biking here. My hands are on the handlebars, and it's not changing orientation at all. So here's another one: oscillation in both phone and the watch accelerometer, about 2 times per second. And the barometer on my phone is telling me that the air pressure is increasing, which is walking downstairs. Yeah. As I go lower altitude, then there's more air above me, and it reports a higher pressure. So, okay, this is a hard one. How about this one? You can just take a gander at that. I hear running, going upstairs. I'm playing a video game. If you guys have ever played this game before, then you've probably done this, where you can cheat by punching the foot pads. So this is what Dance Dance Revolution looked like before Dance Dance Revolution. But so it's important in machine learning to have this other category where, if your algorithm isn't good enough to know for sure with strong confidence what it is, then just tell us that you don't know, and then maybe in the future we can learn how to detect cheating with your watch. So thank you, Joanne.